Good morning, everybody. Today we are going to continue the next hardness testing. Well done. So, friends, lecture of this chapter, that is tensile test, hardness test, compression test, grip test, fatigue test, bending test, shear test, etc. etc. Out of these all tests, few tests are covered in this. And we are going to conduct the experiment yourself and please talk in between instead of putting in chat box. I repeat once again, if I will not be audible, two or three students immediately you can unmute and you can convey message to me. Now, as far as this hardness testing is concerned, majority the testings are carried out with the help of some indenter component. Part is made hard. That part is first part, and second part is if you have tried to make the part hard, the confirmation is carried out by this test. For example, you have carried out hardening heat treatment. Hello.
Yes, sir.
Automatically, I got exit from the meeting due to internet problem. Am I audible now?
Yes, sir. Yes.
Last 5 minutes, I was outside the meeting room and I got automatically outside the room. Now let it be. We'll try. So I will start. My last sentence was I was trying to say कि hardness testing, though it is destructive testing, there is no breaking of the component. Then why the name hardness testing is added in the destructive, classified into destructive testing? Remember, all tests includes breaking of component except two tests. One is hardness test and another is bending test. So bending test, you are going to check the bending of the component. Your part not going to break into pieces. In the same way, hardness testing, you are going to give impression by hard ball or diamond on the specimen. So when you are going to make impression by that hard tool, it is called as indenter, the life of component decreases. That's why this hardness testing is taken under destructive testing. I will repeat once again. In hardness testing, there is no breaking of component, but there is indentation of the specimen with the help of hard ball or diamond. Due to this indentation, the life of component decreases. Hence, hardness testing is taken in the classification of destructive testing. But you can write it somewhere at the upper side. Now, hardness testing is carried out. I told, see, a very simple thing. If you take one some part and if you try to place it or try to indent it or try to make marking on it, if you will not give response to that tool, you can say that part is hard. So now I will tell number of definitions of the hardness. Indentation. Indentation means you are going to make mark with the help of some hard tool. Next, resistance to scratch. So resistance to cut, resistance to indentation, resistance to scratch. So if you take some part A and part B, if this is part A, this is surface A. If I will take the tool and I will try to make the scratching on it, if it will show some scratching, and now I will take another surface and I will try to do the scratching on it, it will not give scratch. Then I can say that this surface is harder than this surface. If this surface is giving scratch, it will be softer than this surface if it is not giving the scratch mark. One more interview question. So many times, friends, it was asked in the core companies. So if you are in the workshop and in the workshop, you don't have any hardness testing machine, how can you express the hardness of particular job? Maybe on indirect basis. Now you have just entered in third year. So you came across one more tool in the workshop, and that is very important. So what I said, if we hardness testing machine and without hardness testing machine, how can we indirectly predict the hardness of your job or workpiece? The answer is there is a file. File means harness. Everybody might have seen file. So let me get answer from your side. Somebody please talk. Rhythm. Rhythm Parmar. You
Yes,
know
sir.
file.
Yes, sir. Yes,
What
sir.
the file about which I am talking, are you knowing that file?
No, sir.
You don't know. You have worked in workshop for one semester. File म्हणजे कानस असे घासण्यासाठी वापरतात बघा. In fitting shop.
Yes, sir. Yes, sir. Yes, sir.
Are you getting my point?
Yes, sir. Yes, sir.
It is called as file. Any other student who don't know? Huh? Rohit Vidate. You know
Yes, sir.
that file?
Yes, sir.
Ask some of the girls. Prerana Ekatpure.
Yes, sir.
Have you seen that file about which I am talking?
Yes, sir. I see.
Okay, very good. So that file is having, you have seen hatching type of shape is there on the file, and that is hard surface. Usually it is used for finishing the components, and that file is harder, and that file is having hardness around 50 RC. Now I will tell the meaning of RC, BHN, VPN in this chapter. RC stands for Rockwell Hardness C scale. Hardness is 50 RC, which is very high hardness. Usually, if some tell me whether it is hard or not, then on thumb rule, it is not giving 100% correct value. Thumb rule, that file is taken, and with the help of that file, we are just putting the scratch marks over that component. If you will get good quality of material removal because of the file, definitely we can say that this specimen is having less hardness than 50 RC because file is of 50 RC. If you will try to give pressure, or if you try to remove the material with the help of file for that particular material, but unable to remove the material, not only remove the material, your file will not able to give scratch mark on the specimen. If that case will happen, we can definitely say that this surface is harder than file. And then you can say that on indirect basis, hardness is more than 50 RC. What is the basic rule of metal cutting? I asked this question earlier also. This is also interview question. What is the basic principle of metal cutting? Answer. काय रिक्वायरमेंट आहे मेटल कटिंगची? What is the basic principle of metal cutting? Dhanashri Sonone.
Yes, sir.
What is the basic requirement of metal cutting?
Tool is harder than workpiece.
Tool is not. Tool must be harder than workpiece. Correct. Good. So this is the basic requirement of metal cutting operation. Your tool should be harder than workpiece. Then only, if file is harder than the piece, then you can only apply the file on the specimen. So scratch, I am talking about scratch. Resistance to scratch is also hardening. Resistance to cut is also hardening. Resistance to indentation म्हणजे एखादा hard part घुसवायचा एखाद्या surface मध्ये. It is called as indentation. If you take some hard nail and if you try to give impact, not by applying hammer, just by pressing I am talking about. And if I am not wrong, this test you have carried out on the mold in the manufacturing process lab. There was a hardness tester, mold hardness tester. Have you seen? Reply. Somebody reply with unmute. Somebody reply with unmute. Samruddhi.
Yes, sir.
Have you seen mold hardness tester in manufacturing process lab during the practicals?
Don't remember, sir.
We have one experiment. I have carried out that experiment with my students when earlier I was talking this MP. I know that 100% we have small unit of mold hardness tester. Who was your subject teacher? Huh? Hello? Samruddhi?
Yes, sir.
Who has, no, whether he has conducted practicals or some other teacher was there for the practical?
Other teacher was there.
Who was there?
Bhuse ma'am.
Bhushe madam has not shown you that mold hardness tester. Okay, let it.
I think that we have seen that.
You have seen, okay. Means some you are not remembering, few students. You should not forget the things, Samruddhi. So mold hardness tester is used for checking the hardness of mold. मोल्ड म्हणजे मातीचा सरफेस असतो सँडचा, त्याच्यावर ते इन्स्ट्रुमेंट असं, दिस इज युअर सरफेस. If you press it, here the pointer will give the readings. So it is forming the indentation. It is forming the impression mark on the surface. So resistance to scratch, resistance to indentation, resistance to cut. Next thing is resistance to rebound. Means if you take it, some component, and if you give or if you apply, if you put on the ground, how much height it can achieve after rebounding. If it will rebound much, then it is less hard. But if it will not rebound much, we can say that it is more hard. So actually all these are on indirect basis, but these are the definition of hardness. You remember: resistance to cut, resistance to indentation, resistance to scratch. Now this third is Rockwell hardness test. Meters. Same way, you are going to measure the length. Same way, you are going to measure the hardness. But if you use these three methods, the unit will be different. Briness hardness test measures in the term of BHN value, Briness hardness number. Similarly, Vickers hardness will also use Vickers hardness number. Rockwell hardness will use Rockwell number. So one by one, when we will study, I will explain you how it is measured. Now next line, write down Briness hardness test. Write down. Now I am telling the test procedure. We are going to perform the experiment in the laboratory. I don't know if we have to explain the instruments also. Let it be. If you will come back to college as soon or at the earliest, physically we will conduct the experiments. We have external oral for metallurgy. Remember, metallurgy subject is not only studied for passing, but as long as you are in the mechanical field, you should have this knowledge of material and metallurgy. Okay, all whatever instruments are first. Works on the principle of area of impression. Briness hardness test works on the principle of area of impression. Make star mark to this statement. It consists of use of hard ball. So generally ball is made up of white cast iron or high carbon steel. The material I'm telling. Ball is usually hard material. You have seen the balls of bearings. Similarly, such balls are there. During the hardness test uses hard ball. Standard test consists of application of and 500 kg load for non-ferrous material. 3000 kg for ferrous and 500 kg for non-ferrous material. You have to draw this figure, but pay attention also simultaneously. Just imagine here D I have written D. Next line. The diameter of ball is 10 mm. The diameter of ball is 10 mm. Now, simple logic. This is the component. Now, there is a hard ball of 10 mm diameter. Ball is not single. Ball is having holder. So, holder and ball togetherly called as a indenter. I repeat once again. Holder and ball togetherly called as indenter. So, assume that there is a ball in this pen at the top. So, you have seen your ball pen. At the tip, there is a what will happen? 10 mm ball and 3000 kg load P. What will happen? Diameter is capital D, ball diameter. It will create impression of small d on the specimen. It will create impression of small d on the specimen. Before I tell the formula of Briness or before I tell the formula of hardness, I want logical answer from your side. Unmute somebody's name I will take. Karuna Sarvade, please unmute. Karuna, please unmute. Am I audible to you, Karuna?
Yes, sir.
Now I am asking you, I am asking the simple question. So I repeat, the 10 mm ball is pressed on the specimen which gives small d as an impression on the specimen. Tell me, if small d is less, hardness will be? Please give answer on logic base. This small d is impression made by this ball on the specimen. Higher the value of small d means what? Hardness will be less or more? Higher the value of small d means hardness is?
More.
Logic you are not applying.
Less, sir.
Less. Then justify your answer. Samruddhi.
Sir, as the value of small d will be less, so we can say that hardness will be more because
Huh? Yes, you are correct. Simple logic. Soft material will form
Sir,
larger diameter of impression. Hard material will form less diameter of impression. That's why definition of hardness is Brinell hardness number is equal to, write down this. Brinell hardness number is equal to load applied upon area of impression. Make square bracket. Write down Brinell hardness number is equal to load applied upon area of impression. Now, how to calculate area of impression? It will be impression of this ball is the sphere. So it will produce some small cut sphere as a shape or impression. And that area is pi dh. H is the height which ball has inserted inside. So if d is larger, area is larger, and it is a denominator. So larger the value of d, smaller with the value of hardness, and lesser the value of d, harder the material. And logically, hard material will give less impression. And now this area of impression pi dh is calculated, and it is further modified. Like this main formula, we are not going to see the derivation there, which is not asked in the exam. Directly load, we know that P. This load is P. Upon area of impression is pi d in, small d. Pi d into h. H is nothing but this much height. It is very small. It is very small. And by using the trigonometric formulas, this value of h is calculated. And directly if you put the value of h, final formula is equal to 2p upon final formula pi d square bracket or round bracket d minus square root of this square minus this square. Now you will ask from where this 2 comes. This 2 comes from the denominator. After solving this, we got the equation. BHN is equal to 2p upon pi d in bracket d minus square root of d square minus d square. And if you want to find out the hardness value, tell me which is unknown. Unmute and tell. Karuna, now at least you tell what is unknown in this formula. Karuna. What is unknown in this formula? Onkar Mashalkar. Onkar. ओंकार माशाळकर लेफ्ट. प्रश्न विचारला की लेफ्ट झाले. Who will tell willingly? Yasser Khatik.
Small d, sir.
Who is replying? Who is talking? Please tell your name, roll number. Rohit.
54, sir.
So small d is unknown, correct, Rohit? Because capital T is known 10 mm, P is known 3000 or 500. So only unknown is D. So once you take the surface and make the impression by ball, your aim is to only measure the D. Put the value of D and calculate the Brinell hardness number. Now, already supplier who has supplied the machine, he started by taking the value of D. D is very small value, 0.1, 0.2, 0.3 in that way. So if you put random values and if you put on Excel sheet formula and you go on adding random values of D, you will get BHN value. So that chart is ready already with known value of small d's. How to perform the experiment? Take the specimen, make the impression, measure that small d. Once you measure that small d, open your chart and check for this small d, this is a BHN. Are you getting my point? Yes or no? Please reply.
Yes, sir.
Are you getting my point?
Yes, sir.
So this is the final formula for Brinell hardness number. Now, what are the drawbacks of this test? Just imagine this is a standard test. Standard test usually carried out in the industries, 10 mm ball, 3000 kg load. So with this much high heavy load, the workpiece may get deformed. Ball may get deformed. And there may be, by your naked eyes, you can see that ball is round. But if you check its ovality, you will find it becomes oval with due course of time. And it may give wrong reading. If you put even small point, not one digit is changed here because it is square, remember, then hardness value will be changed drastically. That's why limitations of hardness testing, Brinell hardness testing are there. So go to next slide. I hope you have drawn this figure. Have you drawn this figure?
Yes, sir.
Now go to next slide. Limitations of Brinell hardness testing. First, sir, ball is likely to deform. Ball is likely to deform due to heavy load. Second, heavy load decreases the life of component. Heavy load decreases the life of component. Third, thin plates are difficult to test. Thin plates are difficult to test. And fourth one, there is piling, P-I-L-I-N-G, right? I will show that figure. There is piling up effect and shrinkage effect. There is piling up effect and shrinkage effect. Which will measure wrong value of small d. Which will measure wrong value of small d.
Sir, voice is not audible.
Here is filling up effect. And this is shrinkage effect. What happened when the material is soft? When you are pressing the ball, that material will pile up. म्हणजे त्याचं मटेरियल वर चढतं, त्या जो काही इंडेंटरचा बॉल आहे त्याच्यावर मटेरियल चढतं. So this is not actual D. Wrong D. And this is actual D. So there is an error in the hardness value. Same way, this is a shrinkage effect. This is a wrong value of D. See here, surrounding material म्हणजे त्या बॉलच्या साहाय्याने साइडचं मटेरियल पण थोडंसं खाली प्रेस होतं. Actual D is here. This is called as filling up effect and shrinkage effect. Now friends, this much large size ball, actually there are some precautions while we are carrying out the experiment, and it is applicable to all types of such experiments. Maybe tensile test, impact test, compression test, fatigue test, grip test, hardness test. Your surface should be very clean and neat. It should be free from oil, dirt, etc., etc. That is the primary requirement. Because of this heavy load, 3000 kg load, 10 mm ball, the machine is synchronized to the shorter values proportionally. The machine which is in our laboratory is not having 3000 kg load. So machine is synchronized or proportionally reduced with all the dimensions. So load is reduced from 3000 to 250 and ball size is reduced from 10 mm to 5 mm. And then in laboratory, the machine is shorter, which I will show you during the experiments. So in that case, 250 kg load and 5 mm ball is used. There are two loads for Brinell. One is 250 kg load and 5 mm ball, and another is 187.5 kg load and 2.5 mm ball. So always remember, in case of these hardness tests, load and indenter, this is oral question or MCQ question, oral as well as MCQ. What are the loads and indenters for XYZ test? So I repeat, we have just studied Brinell hardness. Load is, you have to tell standard load only. Don't tell the reduced load at the laboratory level. What is the load for Brinell hardness test? 3000 kg for ferrous, 500 for non-ferrous. I repeat, 3000 kg for ferrous and 500 for non-ferrous. And indenter is ball indenter, 10 mm size ball indenter. I repeat, 3000 kg load and 10 mm. Load and indenter, you have to remember. So Brinell hardness test is giving its name as a BHN value. Same tests are carried out by another machines, another methods. If you take one particular component, if you check by Brinell hardness test, it gives Brinell hardness value. If you check by weaker hardness test, it will give weaker hardness value. But hardness of the specimen will remain same. Only measurement method is different. So I can measure it as a 10 mm or I can measure it as a 1 centimeter. Both are same. Length is not going to change. But there are some requirements. As per the standard, requirements are you can't check any or you can't use any method for any material. But some trial and error methods were earlier carried out and specifications are given. So these are the materials suitable for carrying out Brinell hardness test. These are the materials suitable for carrying out weaker hardness test. So what are that? What is the scale that we are going to cover next time? Just don't leave the room. I have not taken attendance. I will take it first. Wait. Whether screen is visible? Somebody reply.
Yes, sir.
So I have shared my screen. Whether it is visible? Rohit. Rohit.
Yes, sir. Yes.
So I am just scrolling your roll numbers.
Yes.
So friends, we will stop here. In next lecture, we will study the next type of two hardness testings. Thank you. Notes I will upload within 1 or 2 days.